Hello everyone, welcome back to our physics online class. Today I am going to explain about concurrent forces and Lamy's theorem in the chapter laws of motion. The chapter name is laws of motion. Laws of motion. The topics are concurrent forces and Lamy's theorem. Concurrent forces and Lamy's theorem. Right. First we go for concurrent forces. Right. Suppose, let us consider an object which is on the horizontal surface, right? There is an object which is on the horizontal surface and which is acted upon by a single force, let it be F, right? So F be the external force which is acting on an object which is on the horizontal surface, right? If the magnitude of external force is greater than the static frictional forces arises between the body and the surface, then the body starts to move in the direction of external applied force. Right? So there is a frictional force arises between the body and the surface. Okay. So which is called static frictional force. If the magnitude of the external applied force is greater than the static frictional forces which is acts between the body and the surface, then the body starts to move in the direction of external applied force. Right. Suppose if the static frictional forces or static frictional force balances the external applied force, then the body does not move. Now the body is said to be in static equilibrium. Right. So if the external applied force is more than the static frictional force, the body starts to move in the direction of external applied force. If the magnitude of the external applied force is equal to that of the static frictional force arises between the body and the surface, the body does not move. Then the body is said to be in static equilibrium. Right. Suppose there are two forces acting on this body. Two forces. One is F1 and another one is F2. In this case, the static frictional force is negligible. Okay, suppose let you assume the static frictional force is negligible. There is only two forces acting on this body. One is F1 and another one is F2. These two forces are acting in opposite direction. Right. The net force acting on this body or the resultant force acting on this body is given by R vector is equal to, suppose the two forces acting on the body in vector form is denoted by F1 vector and F2 vector. These two forces are acting on the body in opposite direction. Then the net force or resultant force acting on this body is R vector. It is given by F1 vector plus of minus F2 vector. R vector is equal to F1 vector plus of minus F2 vector, because here the F2, the force F2 is acts opposite to the direction of F1. The force F2 is acts opposite to the direction of F1, right? Already you know the condition. or know the condition, or already you prepared or studied in the previous classes, right? So in vector notation, R vector is equal to F1 vector plus of minus F2 vector. Here F1 vector and F2 vector are acting in opposite direction, right? Okay, here R vector is equal to F1 vector plus of minus F2 vector, or F1 vector minus F2 vector. So from this equation it is clear that the vector sum of these two forces gives the resultant force acting on the body. The vector sum of the two forces gives the resultant force or net force acting on the body. Here the F2 force is acting opposite to the direction of F1, so that is why there is a negative sign. So R vector is equal to F1 vector plus of minus F2 vector, plus of minus F2 vector, right? Suppose if the body does not move either along the F1 direction or F2 direction, okay, then it is also said to be in static equilibrium, or the body now also in static equilibrium. So for equilibrium requires R vector is equal to F1 vector plus or minus plus of minus F2 vector is equal to 0. R vector is equal to F1 vector plus of minus F2 vector is equal to 0. Even though there are two forces acting on a body, the body does not move means then the body is said to be in static equilibrium. So equilibrium requires R1 vector is equal to F1 vector plus of minus F2 vector or plus F2 vector is equal to 0. It means the net force acting on a body should be 0, or the resultant force acting on a body should be 0. Okay, then the body is said to be in static equilibrium. Static equilibrium. If the resultant force is not equal to 0, then the body either move along the direction of a force F1 or F2. If F1 is greater than F2 means then the resultant acts along F1 direction. If F2 is greater than F2, then the resultant acts along F2 direction. If F1 and F2 are equal in magnitude and opposite in direction, then the net force or the resultant force acting on a body is 0. So the body is said to be in static equilibrium. So static equilibrium requires R vector is equal to 0, or R vector is equal to F1 vector plus F2 vector is equal to 0. Okay, if the resultant force acting on a body is 0 means then the body is said to be in static equilibrium. Body is said to be in static equilibrium, right? Suppose there are three forces acting on the body like this. Three forces. One is F1 vector, another one is F2 vector, and the third one is F3 vector, right? F1 vector, F2 vector and F3 vector are the three forces which are acting on a body at point O, right? Okay, here the vector sum of the forces F1 vector and F2 vector is, suppose R vector, it is given by F1 vector plus F2 vector, right? The vector sum of F1 vector and F2 vector is taken as R vector, which is equal to F1 vector plus F2 vector. F1 vector plus F2 vector, right? Which is acts along this direction. R vector is the resultant of F1 vector and F2 vector. Okay, the resultant of F1 vector and F2 vector is given by F1 vector is equal to R vector is equal to F1 vector plus F2 vector, right? So here the resultant of F1 vector and F2 vector is equal in magnitude and opposite to the direction of F3 vector means now the body is in static equilibrium condition. Okay, so F1 vector, F2 vector, F3 vector are the three forces which are acting on a body at point O. The resultant of F1 vector and F2 vector is R vector. Suppose if the R vector magnitude is equal to that of F3 and which is acting opposite to the direction of F3 means then the body does not move. Okay, if the body does not move means then it is said to be in static equilibrium. So for this case, or the equilibrium requires F1 vector plus F2 vector plus F3 vector is equal to 0. Okay, for this case, equilibrium requires F1 vector plus F2 vector plus F3 vector is equal to 0. Right. Here, F1 vector plus F2 vector is equal to R vector. So, R vector plus F3 vector is equal to 0, or R vector is equal to minus F3 vector. R vector is equal to minus F3 vector. Okay. So, it means the resultant of F1 vector and F2 vector is equal in magnitude and opposite in direction to F3 vector. Okay, so this condition is called, in this situation, the body is said to be in static equilibrium. The body is said to be in static equilibrium, right? Or on other hand, if the forces, that is the forces F1, F2 and F3 acting on the same body, all the forces acting at the same point. So in this diagram, the forces F1, F2 and F3 acting on the same body, and as well as on all the forces acting at the same point, right? Now these three forces are called concurrent forces. A collection of forces acting at a same point means then those forces are called concurrent forces. Once again repeat, if any number of forces, either 3 forces or 2 forces or 5 forces, whatever it may be, and all the forces are acting at the same point, or acting at a common point, then those forces are called concurrent forces. The forces are called concurrent forces, right? The concurrent forces need not be in the same plane. In this diagram, these 3 forces acting at the same point, and also they are lying on the same plane. But the concurrent forces need not be in the same plane. Okay, suppose the F1 vector maybe acts along x-axis direction, and the F2 vector maybe acts along y-axis direction, and the F3 vector maybe acts along z-axis direction, right? If all the 3 forces acting at the common point means, then those forces are called concurrent forces, right? Suppose if all the 3 forces acting or lying on the same plane means, then those forces are called concurrent forces and as well as coplanar forces. In this diagram, the force F1, F2, F3 acting at a common point, so they are called concurrent forces. And also they are lying on the same plane, so these forces are called coplanar forces. Okay, so these 3 forces are concurrent as well as coplanar forces. Right? If when 3 concurrent forces are in equilibrium, then the resultant of any two forces is equal in magnitude and opposite in direction to another force. Any two force. Suppose F2 vector and F3 vector resultant is R vector means then the resultant of F2 vector and F3 vector is R vector, which is equal in magnitude and opposite in direction to F1 vector. Suppose the resultant of F1 vector and F2 vector is taken as R vector, and which is equal in magnitude and opposite in direction of F2 vector. So if 3 forces or when 3 concurrent forces are in static equilibrium, then the resultant of any two forces is equal in magnitude and opposite in direction to another force. Right? A scientist, Bernard Lamy, gave his theorem regarding the 3 concurrent forces in static equilibrium. Concurrent forces or 3 concurrent forces in static equilibrium, and is called Lamy's theorem. So Lamy's theorem is useful to analyze the 3 concurrent forces which are in static equilibrium. The Lamy's theorem is useful to analyze three concurrent forces which are in static equilibrium, and also this theorem is used to determine the magnitude of the forces which are in static equilibrium, What is meant by concurrent forces? A collection of forces which are acting at a common point, then they are called concurrent forces. If the forces are acting on the same plane, then they are called coplanar forces. Concurrent forces may be coplanar or may not be coplanar. Right? When three concurrent forces which are in static equilibrium, then the resultant of any two forces, is equal in magnitude and opposite in direction to another force. This was first analyzed by Lamy. Okay, that is why it is called Lamy's theorem. So it is called Lamy's theorem, right? So Lamy who was the first one analyze the concurrent forces or three concurrent forces which are in static equilibrium, right? Okay. Suppose when three concurrent forces are in static equilibrium, then the magnitude of each force is directly proportional to the sine of angle between another two forces or other two forces, which is called Lamy's theorem. So Lamy's theorem states that when three concurrent forces and coplanar forces which are in static equilibrium, then magnitude of each force is directly proportional to the sine of angle between other two forces. So once again, we consider a body on which three forces acting like this. Three forces F1, F2 and F3 acting on a body at point O. Right, here the force F1, F2, F3 acting at a common point, so that is why they are called concurrent forces, and also they are lying on the same plane, so they are called coplanar forces. So these three forces are concurrent as well as coplanar, concurrent and coplanar, right? Suppose the angle between F1 vector and F3 vector is taken as, angle between F2 vector and F3 vector is taken as alpha. The angle between F2 vector and F3 vector is taken as alpha. The angle between F1 vector and F3 vector is taken as beta. And angle between F1 vector and F2 vector is taken as gamma. Right? So there are three concurrent and coplanar forces which are acting at a point O, and angle between F1 and F3 is beta, angle between F2 and F3 is alpha, the angle between F1 vector and F2 vector is gamma. Right? According to Lamy's theorem, when three concurrent forces and coplanar forces which are in static equilibrium, then the magnitude of each force is directly proportional to sine of angle between other two forces. Right? According to Lamy's theorem, magnitude of F1 vector is directly proportional to the sine of angle between other two forces, that is F2 and F3. So sine alpha. The angle between F2 vector and F3 vector is alpha. According to Lamy's theorem, the magnitude of each force is directly proportional to sine of angle between other two forces. Here force is F1, the angle between other two forces is alpha. So according to Lamy's theorem, the magnitude of F1 vector is proportional to sine alpha. Right? Similarly, for F2 vector, the magnitude of F2 vector is proportional to sine of angle between F1 vector and F3 vector is beta, so sine beta. And similarly for F3 vector, modulus of F3 vector is proportional to sine of angle between F1 vector and F2 vector is gamma, so sine gamma. So magnitude of each force is directly proportional to sine of angle between other two forces. Sine of angle between other two forces. So this is Lamy's theorem. So once again I repeat what is meant by Lamy's theorem. According to Lamy's theorem, when three concurrent and coplanar forces which are in static equilibrium, then the magnitude of each force is directly proportional to sine of angle between other two forces. Sine of angle between other two forces. Right. So this condition can also be written as modulus of F1 vector divided by sine alpha is equal to constant. And similarly this one, modulus of F2 vector divided by sine beta is equal to constant. And for this condition, modulus of F3 vector divided by sine gamma is equal to constant. Or otherwise, modulus of F1 vector divided by sine alpha is equal to modulus of F2 vector divided by sine beta is equal to modulus of F3 vector divided by sine gamma. So this is mathematical form of Lamy's theorem. The mathematical form of Lamy's theorem is F1 vector or modulus of F1 vector divided by sine alpha is equal to modulus of F2 vector divided by sine beta is equal to modulus of F3 vector divided by sine gamma. So this is mathematical form of or equation of Lamy's theorem. Mathematical form of Lamy's theorem or equation of Lamy's theorem is F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. F3 divided by sine gamma. Lamy's theorem states that when three concurrent and coplanar forces which are in static equilibrium, then the magnitude of each force is directly proportional to sine of angle between other two forces. Sine of angle between other two forces. What is the use of Lamy's theorem? The Lamy's theorem is used to analyze the forces acting on a body which are in static equilibrium. The Lamy's theorem is used to analyze the forces acting on a body which are in static equilibrium, and also it is used to find the magnitude of force, which are acting on a body and which is in static equilibrium. The forces acting on a body which are in static equilibrium. Based on Lamy's theorem, one simple example problem is given in our book. Okay, example problem 3.14. Right. The question is, a baby is playing in a swing. Which is hanging with the help of two identical chains. Which is hanging with the help of two identical chains is at rest. Right. Identify the forces acting on the baby. A baby is swinging or playing in a swing which is hanging with the help of two identical chains which is at rest. Okay, identify the forces acting on the body. Okay, the forces acting on a body wants to find out. Right. And next, apply Lamy's theorem and find out the tension acting on the chain. The tension acting on the chain. Right. A baby and the chain are treated as a particle is suspended by two identical strings. Like this. This is baby, and which is considered as a particle. And it is suspended by two identical strings. From the rigid support. Right. So this is a rigid support. And this is chain 1 and this is chain 2. Right. Yeah, baby is playing in a swing which is hanging with the help of two identical chains. The chain and the baby is treated as a particle which is suspended by two identical strings from a rigid support. Right. And there are three forces acting on a baby. One is gravitational force. Gravitational force. If any body is suspended from a certain height, definitely there must be a gravitational force acting on a body. Here baby is playing in a swing which is hanging with the help of two identical chains, which is suspended. So definitely there is a gravitational force acting on baby. So one of the force acting on a baby is gravitational force, and which is acting downward direction. And the gravitational force is given by the formula mg, where m mass of the given baby and g acceleration due to gravity in the given place. And which is acting downward direction. And next, tensional force acting along the first string, and the third one also tensional force which is acting in the second string, and they are taken as a T1 and a T2. So there are three forces acting on the baby. One is a gravitational force and another two are tensional force. The tensional forces are acting in the two chains 1 and 2. Right? In this question, first we need to find out what are the forces acting on the baby. Right? Identify the forces acting on the baby. What are the forces acting on the baby? There are three forces acting on the baby. One is a gravitational force, second tensional force, and the third also tensional force. The tensional force acting along the string and the gravitational force is acting along downward direction. The gravitational force is given by F suffix g is equal to mg, or simply mg. So what are the three forces acting on the baby? Gravitational force and two tensional forces. Right. So there is a baby which is treated as a particle, and this is gravitational force mg, and this is tensile force T2. Another tensile force is T1. Right. The tensile force T1 and T2 is acting in the string like this. Right. T1 and T2 is acting along the string, and the gravitational force is acting downward. Right. Here the two chains are identical. Already, okay, this condition is mentioned in the problem. With the help of two identical chains. So since the two chains are identical, so the tensile forces T1 and T2 is equal to T. That is, the tension produced in the string should be same, because the two strings are identical, or the two chains are identical. So the tension produced in the string is the same. So the T1 and T2 are taken as a T. T1 and T2 is equal to T. So T1 and T2 is taken as a T. Right. Now the tensile force T can be resolved into two components. Right. One is vertical component and another one is horizontal component. Suppose the vertical component makes an angle of theta with the tensile force. Then it becomes T cos theta, and the horizontal component becomes a sin theta. T sin theta. Here tensional force is one of the force which is acting on the baby, and it is acting along the string, and it can be resolved into two components. One is horizontal component and another one is vertical component. Suppose vertical component makes an angle of theta with the tensional force, then it becomes a cos component. The cos component is a T cos theta, and another component becomes a sin component, and sin component is a T sin theta. Similarly, this tensional force can also be resolved into two components. One is a horizontal component and another one is a vertical component. Here this vertical component makes an angle of theta with this tension force, so this is cos component. So it is a T cos theta, and this is a sin component, so it is T sin theta. In this diagram, the horizontal component T sin theta are equal in magnitude and opposite in direction, so they are cancel each other. The horizontal components are equal in magnitude, acting opposite in direction, so they cancel each other. They are cancelled out. But the vertical component t cos theta acts along the same direction, so they gets added up. So 2t cos theta. The vertical component is 2t cos theta because the both vertical component is act along the same direction, so they are added up. The net vertical component acting upward direction is 2t cos theta. 2t cos theta. Here the horizontal components are equal in magnitude and opposite in direction, so they are cancel each other, right? So what is the total angle between these two tensile force? The total angle between these two tensile force is 2 theta. This is theta, this is also theta, and total angle between both the tensile force is 2 theta, right? What is the angle between this tensile force and this gravitational force? This angle is theta and this total angle is 180 degree. So angle between tensile force and this gravitational force becomes 180 degree minus theta. 180 degree minus theta. And similarly, angle between this tensile force and this gravitational force also 180 degree minus theta, because the total angle is 180, this angle is theta, therefore angle between this tensile force and the gravitational force is 180 minus theta. 180 minus theta, right? Now apply Lamy's theorem or the mathematical form of Lamy's theorem. Applying Lamy's theorem for this condition or for this diagram, and tensile force T is proportional to sine of angle between another two forces. So T is proportional to sine of, what is the angle between this tensile force and the gravitational force? 180 minus theta. So sine of 180 degree minus theta, right? Similarly, this tensile force is directly proportional to sine of angle between these two forces, that is 180 degree minus theta. So sine of 180 degree minus theta. And the gravitational force mg is proportional to angle between these two tensile force is 2 theta. So mg is proportional to sine 2 theta. Sine 2 theta or t divided by sine of 180 degree minus theta is equal to t divided by sine of 180 degree minus theta is equal to mg divided by sine 2 theta. mg divided by sine 2 theta. So this is mathematical form of Lamy's theorem for this diagram, right? We know that sine 180 degree minus theta is equal to sine theta. Sine 180 minus theta is equal to sine theta. And sine 2 theta is equal to 2 sine theta cos theta. In trigonometry, sine 180 degree minus theta is equal to sine theta, and sine 2 theta is equal to 2 sine theta into cos theta, right? Substitute sine 180 degree minus theta is equal to sine theta, and sine 2 theta is equal to 2 sine theta cos theta in this condition. Then t divided by sine theta is equal to t divided by sine theta is equal to mg divided by sine 2 theta, 2 sine theta cos theta. For our convenience, we choose these two terms. Then from these two terms, t divided by sine theta is equal to mg divided by 2 sine theta cos theta. Right. Sine theta cancel. Therefore, t is equal to mg divided by 2 cos theta. So this equation gives the tension produced in the string or the tension produced in the chain. Both the chains are identical, so the tension produced in the chain is same. So the tension produced in the chain is T, which is equal to mg divided by 2 cos theta. mg divided by 2 cos theta. So tension produced in the string T is equal to mg divided by 2 cos theta, and there are 3 forces acting on the baby. One is a gravitational force and 2 tensional forces acting on the string. Acting along the string. They are taken as a T1 and T2. Since the chains are identical, so the tension produced in the string also same. So that is why T1 and T2 is taken as a T. The value of tension produced in both the chain is T is equal to mg divided by 2 cos theta. T is equal to mg divided by 2 cos theta. So this is very simple problem based on Lamy's theorem, which is given in our book. Right. Once again, recall from the beginning. So first, concurrent forces means if any number of forces or a collection of forces which are acting at a common point, then the forces are called concurrent forces. Concurrent forces, right? Concurrent forces need not be lie on the same plane. If the concurrent forces are lying on the same plane, then they are called coplanar forces. Coplanar forces, right? What is meant by Lamy's theorem? Lamy's theorem states that when three concurrent and as well as coplanar forces which are in static equilibrium, then the magnitude of each force is directly proportional to sine of angle between other two forces. The mathematical form of Lamy's theorem is given by F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. What is the use of Lamy's theorem? The Lamy's theorem is used to analyze the forces acting on a body which are in static equilibrium. And also the Lamy's theorem is used to determine or used to find the magnitude of the forces acting on a body which are in static equilibrium. Okay, Lamy's theorem is used to analyze the forces and as well as to find the magnitude of the forces acting on a body which are in static equilibrium. Right. Thank you, student. We will see in the next class.